Good morning, students. Today we are going to read the second lecture of the current electricity in the subject of physics O levels. So concentrate yourself. The today's topic is electric symbols. So here are some symbols with names. So these are very important because in papers symbols are given and you are required to write the names of the symbols. So concentrate yourself. We are going to start now. This is switch. This is lamp. This is galvanometer. So here are two symbols for the galvanometer. Here is ammeter. This is fixed resistor. This is cell. This is battery. This is variable resistor or rheostat. So this symbol is having two names, and here are two symbols for it. So here is the fixed resistor. So if a slanting arrow is there, this is variable resistor, or arrow like this is here. This is voltmeter. This is two-way switch. This is fuse. This is power supply. This is earth connector. This is coil of wire. This is wires joined. This is wires crossed. This is transformer. And here is the capacitor. So these symbols are very important. You have to learn them. You have to understand them, because out of these symbols, 1, 2, or 3 symbols always come in the paper. Particularly in paper number 1, MCQs, figure is given. Some options are there, and you are required to write to tick the right name of the symbol. So this is very important. Concentrate yourself representing some circuit diagrams using electric symbols. There are 3 basic electric circuits. Number 1, closed circuit. Number 2, open circuit. And number 3, short circuit. So concentrate yourself. We are going to start now. The first thing that we are going to read out of these 3 circuit is the circuit diagram below is closed circuit, because switch is closed here. That is, there is a continuous conducting path around which charges can flow continuously. So the path is complete now. So the charges can flow continuously. Closing the switch completes the circuit. So switch is closed. So circuit is complete now, which switches a current on and bulb will be light on, because circuit is complete and charges are flowing continuously in this circuit. The next thing that we are going to read is the open circuit. Opening the switch. So look now, switch is opened, breaks the circuit. So circuit is break now. So charges will not move continuously. So the breaks the circuit and switches the current off. The circuit diagram below is an example of the open circuit. An open circuit occurs when there is a break in the circuit to stop the current from flowing. So current is stopped to flow now because circuit is break. The break in this circuit can be due to a loose lamp holder. So there are the reasons. So sometimes the reasons always also come in the paper. So the reasons to break this circuit are, number 1, it may be due to the loose lamp holder or a missing wire in this circuit. So these 2 reasons may be responsible for breaking this circuit. So this type of the circuit is called open circuit. The third thing that we are going to read is the short circuit. The circuit diagram below is an example of the short circuit. The wire A, so look now, here is the wire A, acts as a bypass for the current flowing out of the positive terminal of the cell. So look now, from positive terminal of the cell into the negative terminal. So look now, without flowing to the rest of the circuit, without passing to the rest of the circuit. It is easier for the current to flow through wire A than the rest of the circuit. The current in wire A may be very high and possibly dangerous. So it is very dangerous to touch it. So look now, ammeter shows no reading, light bulb off and switch closed. So this is a bypass. So this kind of the circuit is called short circuit. Figure below shows another example of the short circuit. So look now, light bulb off as current bypasses it by flowing through the wire B. So this is a wire that actually bypasses the current and does not allow the current to pass through the bulb. So figure below shows another example of the short circuit. Here is a question, study the circuits in the figure. So here are 1, 2, 3, 4, 5 circuits are there. The switch S is open. So look now, in all these circuits, switch S is open. So circuit is break. So look now, this circuit in which lamp P would not light, but lamp Q and R would is. So P will not light, but Q and R will light. So look now, in A part, if switch is closed, so P will not light because current will not pass through the P now because circuit is break. So in this B part, here is circuit break, so P will not light up, but this is a bypass, so Q and R will light up, but P will not light up in circuit B. So circuit B is the answer. In C, you can see here is circuit break because of the switch on, so Q and P will not light. Here is switch on, so circuit is break, so PQR will not light. Here is switch on, so circuit is break, so RQ will not light on. So B circuit is the only one in which P will not light on, but Q and R will light on. So look now, B is the answer. The next thing that we are going to read is the diode. A diode allows the electric current to flow only in one direction. So this is very important point to remember. Diode allows the electric current to flow only in one direction. When diode in forward bias, lamp lights up because current will flow in one direction. When diode in reverse biased, lamp does not light up. So this is forward biased and this is reverse biased. So arrow sign is telling us. Current flows easily in this direction because diode allows the current to flow in one direction. So this is forward biased. The forward arrow on the diode symbol shows that the diode is forward biased. The current flows easily. But when the diode is reverse biased, so the reverse arrow shows that the diode is reverse biased, the current is nearly zero. So you can see from here. So this is reversed bias. So nearly zero is the current, whereas this is forward bias. So current can easily flow. A current can only flow through a diode in one direction. They are used to control the direction of the flow of the current through complicated circuits, such as those used in radio, which have components in series and parallel. So diodes are normally used in complicated circuits, for example, radios, in which the flow of the current has to be flow in one direction. Diodes have a band marked at one end. When the diode is connected into the circuit, the end with the band on must be connected to a wire coming from the negative terminal of the cell or battery for the current to flow. When a diode symbol is drawn in a circuit diagram, this symbol should be drawn with the straight line facing the negative terminal of the source of the current. So this is the straight line. Light emitting diodes. A light emitting diode is often referred to as LED. In simple circuits, we often use a lamp to show that a current is flowing. In electronic circuits, an LED performs the same task more efficiently. So electronic circuits use LED, whereas the simple circuits use a lamp to show that the current is flowing. An LED is a semiconductor diode allowing a current to flow in only one direction through it, and it produces light. So it produces light. An LED can emit red, yellow, and green light. The color emitted depends on the semiconductor material used to make the LED. So this is the thing which is used in electronic circuits, LED. The next thing that we are going to read is the rectifier. In a direct current or DC current, the current only flows in one direction, that is from positive to negative direction of the conventional current. In an alternating current or AC current, the power supply can be controlled in such a way that the current alternates between forward and reverse directions, that is from positive to negative for a short period, then from negative to positive for an other short period. So this is very important point to remember, students. In DC current, the current flows only in one direction, whereas in AC current, the current can be controlled in such a way that current alternates between forward and reverse directions. That is, from positive to negative for a short period, and then from negative to positive for another short period. So this is the difference between DC and AC currents. Since a diode only lets current flow in the forward direction and stops all the reverse current, and AC can be changed into DC by using a diode, because AC can alternate the current, so we can make the flow of the current in one direction by using a diode in AC currents. The conversion of an AC into DC is called rectification. The diode used to achieve rectification is called rectifier. Here is another very important topic, that is halfway rectification. In halfway rectification, the diode conducts in the forward half cycle of the AC, forward biased, and cuts off the reverse half cycle of the AC. So halfway rectification is that one in which diode conducts only the forward half cycle of the AC and cuts off the reverse half cycle of the AC. So here is a figure. that will show us. The graph shows that at time intervals 0 to A and B to C, the diode allows the current to pass through. So look now, 0 to A and B to C, because forward half cycle is allowed to pass, not for time interval A to B and C to D. So look now, A to B and C to D. Here was actually the reverse current that is stopped. This is called half-wave rectification. So here is a question now from the half-wave rectification. The diagram shows a circuit which includes a suitably adjusted cathode ray oscilloscope (CRO) with its time base switched on. Which trace would appear on the screen of the cathode ray oscilloscope? So look now, this trace will be appeared on CRO because forward half wave is allowed to pass, whereas the reversed half wave is stopped. So D will be the answer. The diode allows current to flow in one direction only, and so only half the wave form can be displayed. Here is an example for you. The CRO is used to display electrical waveform. The voltage from the AC main supply is sinusoidal and is not a square wave. So, not a square wave. Okay, the next thing that we are going to read is a look inside a typical dry cell. The dry cell consists of the carbon rod which act as the positive terminal. So look now, here is the carbon rod which acts as a positive electrode, that is cathode. It is enclosed by an electrolyte paste. So here is electrolyte paste that encloses the component. Okay, the zinc sheet that encloses the contents act as the negative terminal. So look now, here is the zinc sheet that encloses the components, acts as the negative electrode, that is anode. When connected to a bulb, a chemical reaction occurs which converts stored chemical energy into electrical energy. This causes electrons to flow in this circuit. So electrons causes to flow and bulb will be light on. The next thing that we are going to read is arrangement of cells. Most battery operated appliances use more than one dry cell for power. You ever have used some electrical appliances that actually use more than one dry cell? 2 or 3 or 4 cells are used normally in your sports cars or whatever the things you use, for example torches. So look now, you may have noticed that such appliances will indicate how the dry cells should be arranged. Why do you think this is necessary? For example, when you use cells in your torch, these cells are arranged in series. But normally when you use cells in your sports cars that are actually used by the kids in our houses, these cells are arranged in parallel. So why are these arrangements? So look now, the number of the dry cells and how they are arranged will determine the amount of the EMF supplied to an appliance. In general, there are two arrangements of the dry cells, series and parallel. So actually these cells provide EMF. So the arrangement of the cells will determine the amount of the EMF. The combined EMF will depend on whether the cells are connected in series or in parallel. So look now. Here is electrical appliances in which cells are arranged in series. When the cells are arranged in series, the combined EMF is increased because the electric charges gain electrical energy from each cell when they pass through them. So when the cells are arranged in series, the combined EMF is increased. Two 1.5 volt drive cells connected in series to a bulb, whereas the cells in parallel. When two identical cells are arranged in parallel, the energy required to move electric charges through the load, that is bulb, will be contributed equally by each cell. So the EMF required will be contributed equally when cells are arranged in parallel. Thus, each cell only needs to provide half the energy to move the charges through the circuit. So this is the thing, students. This is the difference between the series and parallel. Two 1.5 dry cells, volt dry cells connected in parallel to a bulb. So this was the lecture, students. This was the second lecture of the current electricity. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.